In this video, we're going to work on polynomial functions, finding zeros and factors for those functions. And remember that the degree of the function tells how many zeros there are. The function is x to the fourth minus 3x cubed plus 5x squared minus 27x minus 36. Because 4 is the highest degree, we know that it has 4 zeros. Now, on my calculator, I see that it touches. I want to graph it first and see where it touches the x-axis. The places it touches the x-axis will be the real zeros for the function. It touches the x-axis at -1 and +4. So 2 of the 4 zeros I have to find come from the calculator. X equals -1 and x equals +4. Now, I have to find the other 2 zeros unless there's some multiplicities, and this one is one I picked that doesn't have multiplicities. So what we're going to do is synthetic division with these two numbers. And remember, in synthetic division, you have to make sure the terms are in the correct order, descending order, and you have to watch for missing terms. There's not a missing term because we have an x to the fourth, x cubed, x squared, x, and constant. So we're going to use our zeros, and it doesn't matter which one we do first. I'm just going to use -1 into our coefficients, 1, -3, 5, -27, and -36. And remember, on synthetic division, you start by just bringing down the first number. After that, it's repetitive, like long division. You multiply and add. You take the number that's up there, the -1, and you're going to multiply by everything that's below the line. -1 times 1, -1. We add these now and get -4. We multiply and get +4. Add, we get 9. -1 times 9 is -9. Add, we get -36. Multiply -1 by -36, we get +36. And our remainder is 0. The last number on your synthetic division is always your remainder. And as long as you're finding zeros for a function, you should always have a remainder of 0. If you don't, then that tells you you've done something wrong, added wrong, multiplied wrong, or left out a 0 for a missing term if you had any. Now, we have a fourth degree. We need 4 zeros. Remember, synthetic division lowers the degree. Now we've lowered our problem down to a third degree. We're going to use these new coefficients in our next synthetic division step, and this time we're going to use +4 to find those 3 remaining zeros. I start by bringing down the 1, multiply 4 times 1 and get 4, add 0. 4 times 0 is 0, add, we get 9. 4 times 9 is 36, add, we get 0. And again, should get a 0 if you're finding zeros for the function. That lowers our problem down to a second degree. And that degree is important so you know when to stop. We want to get to a second degree so we can work with quadratic equations. We know how to work with those from the first chapter. We can factor. We can use the square root method or quadratic formula. These numbers are the coefficients for each degree. Since we're down to a second degree, this is my coefficient for my x squared term. This is the coefficient for my x term, and then constant. So the problem now we have to work with is x squared plus 9 equals 0. Once you get to a second degree, set it equal to 0 and solve. And on this one, because we've got squares and constants, square and a constant, we want to use the square root method. So I'm going to start by moving the 9 over. It becomes -9. To get x by itself, I take the square root to cancel the square. Do the same thing on the other side. And remember, when you put a square root into a problem that wasn't there to begin with, you always have to put a plus or minus with it. We have a negative under the radical, and that makes our answer imaginary. Square root of -9 is 3i. So the last 2 zeros we get for the function are +3i and -3i. So we go back up here, we see the 2 numbers we got from the calculator are -1, +4, and now we have +3i and -3i that we got from our work with the synthetic division. So that accounts for all 4 zeros for the function. Now, as far as factors, here are the zeros that we got for the function. When we create factors, the factors are opposite signs basically, because whenever we have a factor of x plus 1 and we set it equal to 0, we get an answer of x equals negative 1. And the same thing's true with all these. If I set x minus 3i equal to 0 to solve for x, then I get x equals positive 3i. So these are the zeros for the function. And then the factors we have right here. This is how the function would factor. You've got 4 zeros. You also have 4 factors. No duplicated answers, no multiplicities, so you've got 4 different zeros and 4 different factors. And so we have the zeros and factors for a polynomial function.